Right, okay, so Jessica's given us a bit of an introduction to who Archetype are. We're a practice that's been around for about 37 years now. We have 3 bases. Our most recent one was established in Edinburgh in 2018 in response to Scotland's really ambitious climate policy targets that they've set. We also offer a kind of a sister consultancy alongside our architectural services called Perform Plus, which is mainly dealing with building aftercare, building physics, energy modelling, post-occupancy evaluation, etc. And we've been kind of offering it as a service for years, but have kind of identified it as a separate service to the architecture section of the practice in recent times. As Jessica's mentioned, we've spent 15 years now developing passive house non-domestic projects in the UK at varying sizes, aesthetics, locations and typologies. Here's just a couple on the screen, and today's focus is going to be on schools and school design. And so what underpins a lot of our design is the post-occupancy evaluation we've been carrying out, particularly on our earlier schools, even some of the non-passive house schools at the very beginning, where we actually have a really good track record of that proof of performance, that proof of concept, and that's so important when we are speaking with clients and convincing clients, and particularly in this era now where indoor air quality and health and well-being has become very at the forefront of decision makers' minds. So what does that mean for generally our approach to passive house projects? Well, the very most important element to us, and I'm sure many of you around the table will agree tonight, that the brief and establishing what those requirements are really, really important. And just for those of you across the water, this is a representation of the Reba plan of works, so the architectural plan of works for the UK, the Royal Institute of British Architects. And what we've done quite a bit of work almost beyond this workflow diagram to look at how passive house is incorporated into that workflow, and actually working with Reba and the Passive House Trust in the UK at the moment to really formalise that as an information flow to help architects and help the industry in the UK. And really the critical element of that for us is the post-occupancy, the reflection, and then the redefinition of that. And we might touch on some of those aspects later on in terms of informing that design. Now, of course, in my 15-minute slot today that Zach's timing me avidly on in the corner, there's so many topics and so many areas that we could talk about, but I'm going to focus on a couple of different areas: costs, post-occupancy and air quality, and the typical design approach, and just end with a couple of built case studies and one key study in Scotland that's just under development at the moment. So there's a PhD that we can written on that one page, and we can, welcome to discuss some of those topics afterwards today. So how do we approach passive house design? In that cyclical collaborative relationship that we've established with the workflows of architecture in the UK, we're always looking to seek out the simple form and the reductive form. And again, many of you around the table will want to push that and kind of, implement that on your projects, and have probably been doing so already. And a really simple example of this is a project we're working with in Scotland at the moment that's about to go to site, where the original school was facing east and west. And instead of saying, okay, look, we'll just put the replacement school east and west alongside, we actually pushed the planners and the client to turn the project to a north-south orientation, which helps with passive house keep the form simple as well, but also it gave a connection and it had a sense of architectural place in terms of that simple massing option. Again, on other sites, that drive to try and be within 15 degrees of south, and aware that all over America there's a certain desire or lack of desire to maybe be totally south, because it will, there's very diverse climates across America. So what we're looking at here may not always be representative of the most optimized form for your zone. And looking at that form factor and surface area to volume ratio as much as we can as we design. Because as an architect myself, I can say this with gusto, we love complexity. We like adding kind of motifs and kind of symbolism or devices to our design that kind of reflect an alleged ethos. And really the ethos at the moment is the climate emergency, and how does that provoke a response from designers. And really what it should respond is not buildings that are very additive in their design and creating lots of complexity for the contractor to build. We want to create real simplicity. It maybe cannot always be as abstract as the Imperial War Museum here is, the archive that we worked on in near London. But that ethos or that simplicity principle needs to be there. That doesn't mean that we can't have complex forms or larger forms that are east-west facing, or H blocks that need to accommodate a client's brief. We just need to be very mindful of how that is driven through design. So on the left, we'll talk about Curry later on, and on the right, that's Harris Academy, Sutton, which I'll also touch on briefly. The approach to the glazing, again, as architects, we love to overglaze, and some of our own lessons learned from our own post-occupancy has been about reducing the size of glazing and only using the glazing where it's most useful to us, which is typically above 800 mil in our part of the world in the UK, and really having stringent requirements around day venting, day lighting, and night venting as strategies alongside the MVHR solution, and also integrating that into the architecture. So the deep reveals on the enterprise center on the right hand side with innovative scroll bale, and the integrated shading on the left from Harris Academy. And we try and avoid too much additive shading to architecture where we can. We like keeping the details simple and repetitive, again, where we can, where the client allows it and the brief allows it. And we also know that engineers love design complexity and additive kit and new technology in their designs. And what we strive to apply as a strategy is also challenging the engineers and design teams to reduce the amount of peak kind of risk they build into their designs as much as possible within reason, and drive for that simple approach. And that leads to reduced services, reduced embodied carbon of services ultimately. And in this situation, which was a gas radiator on the right hand side in one of our classrooms, a really, really tiny radiator. And as we decarbonise, we're seeing these radiators maybe extend to 1.5 or 1.8 meters high by 300 or 400 mil wide, which is much, much smaller, probably a quarter of the size of radiator you would have had in a traditional school with a high temperature distribution network. We use PHPP at every stage. So we don't just kind of use it at planning and a construction stage and hope for the best in the meantime. We're constantly using it as a design tool, which does take time and can take extra time and hours on a project, but we feel it's really worthwhile. And that evidence is seen through all our reporting through the Reba stages, that we're very clear and transparent with the client at all times where the risks are, how we report on those risks, and how far we are away from maybe the idealized design because of their brief requirements. And I suppose, kind of a bit of a provocative statement here for clients and for design teams, are we really wary of trying to design better quality buildings? And the quality agenda in Scotland in particular at the moment, because of previous construction failures, is really, really relevant and prevalent, and also occupant well-being. So really, if we're not designing to passive house, what are we actually offering as a product? Because it's essentially a building as a product. If we had a car with dodgy air conditioning, unfortunately, or a leaky draft stripping around the doors, we bring it back to the garage, but we seem to just sit in buildings that are leaky and are defective and are poor quality and bad for our health, and not actually really complain or do anything about it. So really, as designers, we shouldn't be allowing that to happen. We should be really collaborating away from that. So some specifics, in particular, just air quality. I just wanted to show you this graph from a classroom in Scotland in February 2019. This was a new build school that had very serious, across 6 classrooms, that had very serious levels of CO2 concentration, up to 3,500 parts per million in key points in the day. Now, there was various post-occupancy evaluation done on this. There was a misplaced kind of ventilation strategy that was both natural and mechanical in February. And we had user issues with how people engage with the facade. This is another study where we've looked at, similarly, we have the World Health Organization and parts per million limit at the top there, 5,000. And we have 2 benchmarks on air quality that have been used in the UK over the last couple of years, 1,000 parts per million, which is the new ventilation regulations for school, and 1,500 parts per million, which was the previous one. And we can see in this conventional 1970 school, there was wild variation on this particular December monitoring period where this was taken. This was a study of a 1970 school as a benchmark and a larger POE study. This was an example of one of our own BREEAM excellent schools, or BREEAM very good schools, from 10 years ago, where yes, we have improved on the conventional requirement. And in the summertime, for example, of course, because we had windows open, we were well below the 1,000 parts per million limit. But during the day, because it was naturally ventilated, no mechanical ventilation, there was no control. By contrast, Wilkinson Primary School from 2014, a passive house that was completed, was coming almost, well under where the COVID guidance is sitting currently in the UK, which is to sit below 1,000 parts per million for most of the year, with a little bit of peaking in the wintertime in that late afternoon period, as indicated in the blue. So I think it's quite a powerful set of graphs to look at. This is a school that was a new build, 2018 delivered, and we're looking at a school from 8 years ago that was delivering far, far better air quality, that was passive house. And I would make the comment that that first graph we've shown was definitely not a passive house school. Why is ventilation important? Well, we're all probably exhausted from listening to the implications of COVID and the aerosol distribution impacts of COVID. And there's been a load of risk factors associated with COVID and good indoor air quality, especially in this post-viral world. There on the left there, It's not always building led, it's occupant led and other environments led. And the solution in the UK at the moment, not sure if it's the same in America, is that, it says, put the heating on in the winter, leave all the windows open, that's the best solution to avoid, infection. And what we're saying is that we need to carefully consider airflow, look at mechanical ventilation, look at the evidence from schools that we've collected on CO2 levels that can be very low level and very healthy, and take that forward as a strategy in a more kind of clever, informed way than just letting all the energy flow out the window because of COVID being a risk, and look at the other risk factors around how we manage that kind of virus in a post-viral world. Costs. I feel like I have quite a lot to say about costs, which we'll cover in the Q&A, but a couple of introduction graphs. Of course, there is some extra costs in terms of immediate capital, where you're looking at more insulation, windows, air tightness. Sometimes people aren't even aware of how where to begin with air tightness. So that's always a big knowledge curve as well. And installing MBHR, but actually, in fact, in schools in England and in Scotland, BB 101 almost mandates that you must use a mechanical ventilation strategy. So the MBHR is not as uncommon as it might have been in previous years. So really, is it extra against current cost metrics? We would argue not. There's some reduced costs if you have an intelligent, informed design, especially around heating systems, keeping the form simple. So again, that kind of new environmental vernacular that the climate emergency should be driving, that we just don't see enough of yet, and reduce reliance on renewables, because we don't want them to offset, we want them for generation. And we would argue then that there's nil cost. There's a simpler form to construction and detailing and collaboration that allow that cost to remain very low. And again, if you say that something's passive house and someone prices in 10% risk or 5% risk because of that, well, then every doorknob, every piece of joinery, every piece of kit that's put in that building has that 5% risk tag add to it. And we really, price is a matter of priority, and we need to be very careful how we manage that. A couple of bits of evidence from previous schools. So back in 2015, we were delivering above DPC levels, so excluding all of the abnormals that you do have to deal with on sites. We were dealing with, and excluding all the crazy inflation that's happened since then, of course, we were dealing with projects, £1,200, £1,300 per metre squared above DPC, and that was reflected in two completely separate studies. One with a contractor we came in partnership with over 5 schools, and another separate funded cost study review on the right as well. Recent cost metrics on Scottish passive house schools. So again, the metric is now included for enhanced quality, enhanced statutory requirements in Scotland, the mandating mechanical ventilation, and an allowance and enhancement for quality. It's been reflected in Scotland that the construction quality in the public sector has been very poor for a number of years. This study illustrates that the new Scottish Future Trust metric has an allowance for passive house in it, and this is just benchmarking a recent passive house school cost exercise against 2 previously completed non-passive house schools. So yes, we're a little bit over primary school B, for example, but we're still well within the current metric. And this is important when we look at capital costs, because even a capital cost last year or 3 months ago at this particular point is not maybe as relevant, or it cannot be kind of directly compared. So there is a kind of complexity around how we approach the capital cost agenda. We built all these schools for standard budgets in England 8-9 years ago now, and in Wales. The Enterprise Centre, which was a very low carbon building, so we had novel straw cladding, timber frame CLT, etc. That came into the median cost range in 2015 for university buildings for that particular university within the 10 years. And there's an illustration of the project's finishes. So again, more what would be viewed as high-end finishes. And again, then our first secondary school, passive house secondary school, completed in 2018, came into the kind of median range of costs as well. So below the metric we just looked at there from Scotland. And again, this was CLT with concrete, a high level of timber, exposed specialist finishes. And again, we were looking at a reasonably competitive cost per metre squared for a London project. And just to finish off, after running through all of that, a specific focus on Curry Community High School with City of Edinburgh, which is currently at Reba stage 4. So we're preparing the production and code drawings to send that to site early in the spring next year. It's a replacement school for a very kind of poor conditioned 1,000 people secondary school in just southwest of Edinburgh. It's more complicated form, or more extrapolated form, because of the brief requirements. And we have swimming pools, sports facilities, cafe, library, a lot of integrated society or community function into this school. So Edinburgh is looking to consolidate their buildings into kind of more sustainable, high value assets as they move forward over the next 60-year life period of these schools. And there's a lot of innovation in the pedagogy and learning approach to the school in terms of linked faculties and how learning plazas are used. So again, don't have a lot of time to talk about that today. And again, we have a certain energy metric that we need to meet for Scottish schools now. We're more than complying with that. And just as an interesting side note, because this school has a swimming pool, we're actually working directly with PHI and Jessica in particular on 5 PHPPs for this school. So warm is, we have 2 Passive House certifiers on the school. And we're developing that as well as the stage 4 drawing packages. Just as a note, just some of the particulars in terms of the basic kind of glazing spec and U values that we have in. And again, it's not ideal U value ratios because obviously we have lots of classrooms facing north, so we need to accommodate a high glazing ratio to the north. So that's again been sensitively managed with the energy balance of the whole building envelope and the internal heat gains. And I think some of you may have across this already in terms of small power and how we look at that load and modelling. We need to be very careful around the usages and the timetables and the small power impact of our internal gains in these buildings. And probably in America, you're much more attuned to that with more cooling demand in certain regions than heating demand. A little bit of an indication of the internal of the swimming pool. We can come back to that in a bit more detail about how we managed to make the swimming pool a little bit more efficient than other types of projects. And again, just an element of finishes, which are referencing Scottish context, and just some images of the actual building as it is finished at this current production information stage. You can see just examples of integrated shading and different elevations. Again, you're welcome to pop back to some of those in the Q&A session. And this is part of a wider remit of schools we're doing in Scotland, where we are hitting these energy targets and providing various different educational needs across several projects at the moment, always benchmarking against Passive House on this metric as well. And I suppose just as an example, Edinburgh City Council have been a really leading client in Scotland, where they've mandated the Passive Houses what they want as a requirement for all of their new schools. We're currently doing a study with them on the retrofitting of their 50% of their existing school estate, with a couple of ENERFIT level projects already being instructed to progress as physical projects. And they have many schools in the pipeline for this next wave of educational funding that they have. So again, you know, they visited some of our projects down south in England and lots of reading and referencing, and went to different kind of workshops and studies over a period of 2 or 3 years. And now they've really, even though they haven't delivered a Passive House project quite yet, they will have in 2 years' time. And they've really embraced the quality and quality assurance aspects of the standard as part of their quality agenda for approving kind of buildings and buildings for people, essentially. Okay. And then, yeah, just an example of a couple of the other high kind of large scale projects we're doing across the country at the moment. 1 or 2 completed and others still in design. Again, all aiming for Passive House. So there's a slow trickle of kind of increasing larger scale clients being more involved and actually kind of taking more account of the net zero approach that's been implemented in England as well as and Scotland, as well as the fabric benefits and comfort benefits of Passive House. So that's me. I don't know if I'm actually, if I've hit Zach 15 minutes or not.
That was incredible.